What's up guys, today we are going to do anonymous playground from TryHackMe, which is relatively a harder machine. We started by exploiting a web vulnerability inside of a cookie which reveal information we are not supposed to see, and then we gain initial access. After that, we needed to reverse engineer a binary and exploit a buffer overflow vulnerability, which leads to horizontal privilege escalation. Then we exploit a wildcard injection vulnerability to become a root user and completely compromises the entire machine. Also, I would like to tell YouTube that this video is for educational purposes only. All attacks are performed inside of simulated environments. Now, without wasting time, let's dive into the video and see this stuff in action. Okay, so here we have the IP address. We are going to copy it, and we are going to the terminal, and we are going to scan it using nmap. We are going to say nmap-scv for service enumeration in default scripting. We are going to say -pn to disable pinging the box. We need capital letter P. And we are going to say -T3 for timing template or the speed of the scan. I'm just setting it to 3 to avoid false negatives or false positives. And after that, we are going to say -VVV for verbosity, so that the information will be displayed on the system. And I'm going to paste the IP address, and I'm going to hit enter. And right off the bat, we can see there are two ports that are open. We can see port number 22 and port number 80. So let us start by checking the port number 80 to see what we can find over there. So for that purpose, we are going to the web browser over here, and you are going to paste the IP address, Control V over here, and you are going to hit enter. After hitting enter, we can see the website that is being displayed over here. And this website has the three endpoint over here. We can see there is home. If we click at it, it is going to redirect us to the same page. And if we go to the operatives or the users inside of this website, we can see that there is a lot of users over here. Okay, so it means that this website consisting of these particular users, or in this themed machine, these are anonymous operatives. Okay, so if we go to contact, there is nothing over there. But if we navigate to the robots.txt, let us see what we will find over there. If we go to robots.txt over here, we can find there is one directory over here which has the disallow entry over here, which means we are not supposed to be able to go to this endpoint. But as a hacker, you need to go ahead and try to see if they indeed enforce this particular entry over here. So if we copy this one out and paste it in front of the IP address like this and hit enter, we can see we are able to see that endpoint, but we don't have any access to view the content on this particular endpoint. And for that case, we are going to inspect elements to see what kind of measures they have put to prevent us being able to access this particular page. We are going to the inspect over here, and we are going to the networking over here, and you are going to refresh the page so that you can see the network request over here. After doing so, we are going to the endpoint over here, the endpoint that we are currently in. And if we go and observe the field, you can see the set cookie button over here, and the access is set to denied. Unfortunately, we cannot modify this denied to granted to see if we can access the content of this particular endpoint. To do that, I have gone ahead and downloaded this particular extension over here called the cookie editor. You can go to Google and type cookie editor extension for a particular web browser you are using. For me, I'm using Brave. So if we click on this extension over here, it is going to ask if we need to see the cookies on this particular site. So we are going to say this site over here, and you are going to give it access to see the cookie on this particular site. If we open it again, we can see there is a field called the access, which is the cookie set by the website developers. So if we go ahead over here and try to edit this cookie over here and say granted, we are just trying to see if it will agree or not. So if we save this one, we can see the green light. So let us try to refresh the page and see if our attack or our experiment is successful. So if we hit enter over here, we can see we are able to access the content that we were not supposed to see inside of this endpoint over here. And we can find there is this strange string over here. And this is part of CTF, or capture the flag competition or challenges. And we need to think of a way where decode this particular string over here. But if we go to TryHackMe over here and click hint, it says that you are going to want to write a Python script for this ZA equal to A. Let me explain what does that mean. Here they said that Z, then capital letter A, I believe something like this, is equal to A. What does it mean? It means the following. Here we are going to have, let me increase the font. Let me increase the size of the font over here. It means that the position of Z character is position number 26. Then we are going to plus that position to the position of this letter over here, which is A, which is 1, and the answer will be 27. Then after that, we need to take this 27 and perform a mod operator or remainder operation on the 26. Or in other words, we are going to divide 27 with 26. If that makes sense, it is like typing something like this one. 27 divided by 26 or something like this. And the remainder will be the answer to this particular operation over here. And for this one, the answer will be 1 because the remainder will be 1. And this remainder, the answer over here, will represent the position represented by these two letters combined. So, for example, if we have something like, let me say, BC like this one. For example, small letter B and capital letter C. For this one, we are going to perform the same operation. B is the second letter, so it will be 2. Then we are going to plus with the position of C, which is 3, it will be 5, right? And then, after that, we are going to say 5 mod 26, which the answer will be 5. So, these two letters B and C will represent the 5th letter on the alphabet, which is A, B, C, D, E, which will be letter E over here. So this is how we need to decode that particular string. So if we go over here, we can either do it manually or we can write a script. So luckily for me, I have the script already. So if I go ahead to my directory where I've saved is a Python script, I can go to CD to downloads, then to master tvt, and if I say ls, we can indeed see I have this script over here. So this script is going to do exactly what I just explained from that Google Doc over there. So for me, I'm just going to run it. You can go ahead and let me show you the code, how it looks like. Okay, encoder.py like this. This is how it looks like, but it is going to perform exactly what I just showed you over there. So it is just going to decode each particular pair of letters into their individual letters so that you can see what do they represent. So if we go, I go ahead and run this particular script, Python 3 encoder.py like this, and hit enter, we can see this is an encoded string, and here is the decoded output. And if you are familiar with computer stuff, you can see that this and this one represent username and the password for that particular user. So to continue from here, we need to check the output from Nmap, the Nmap scan we did earlier. If we go ahead and check for the Nmap, we can find that we have port number 22, which is also open. We can try to use the found username and the password to try to access the SSH server. So to do that, we are going to say SSH, and we are going to provide the username at the IP address for that particular server. I believe it is there. No, I need to go ahead and copy it again. So I'm going to this window over here. I'm going to copy the IP address. I'm going to paste it on my terminal over here. Ctrl+Shift+V. Oh shit! I need to go and copy it again over here. I've already copied it, and I'm going to paste it over here. And after that, I'm going to copy the password as well. Copy this one out, and I'm going to hit enter. It is going to ask me the cryptographic questions, but okay, I did it earlier, that is why it is not asking. So I'm going to paste my password, and I'm going to hit enter. And after a while, it let us in. So now we are inside of that particular machine, or in other words, we have gained initial access on this particular machine. So the next thing to do is to perform LOS to see what files are here. So we can see we have this file called flag.txt. We can go ahead and read it. We can say cat flag.txt, and we can hit enter, and we can copy this particular flag. This flag is the proof that we have successful gained initial access. So we can copy this one out, and we can go ahead and paste it over here. Okay, if we paste this one and submit, it is indeed correct. So now it is the hunt for flag 2. And I hate to say this, but we are not hunting flags. We are actually performing computer security stuff, and the flag will be like a proof that we indeed successful perform that particular attack or that particular exploit and stuff like that. So don't think of hunting flags, think of solving cybersecurity challenges and improving your skills. So okay, this is VPN. So if we go ahead over here, we can see there is this binary over here, and there is this note over here, or text file over here. So the very first good thing to do is to read this particular note to see what happened, what is inside of that note. So for that one, I like to use less command, but let us try to use cat to see if it display better. So we're going to say cat note from Spooky, and if we read this one, it says, "Hey Magna, check this binary I made. I've been practicing my skills in C so that I can get better at reverse engineering and malware development. That is good job. I think this is a really good start. See if you can break it. I have had the admin install Radar 2 and GDB so you can debug and reverse it right here." So in other words, this user called the Spooky, this is Spooky user over here, has already installed the tool known as Radar 2 and GDB. But for this video, we are going to use the Radar 2, which is one of the debuggers, if I'm not mistaken. So the next thing that we need to do is to analyze this particular binary to see what we can do with it. So the first command I'm going to run is called file to see which kind of file it is. So I'm going to say hack the world like that and enter. So right off the bat, you can see set user ID, which means we can run commands on this particular binary as another user who set this is set UID flag. But for now, don't worry about it. And it is 64-bit executable for Linux, and it is also not stripped, meaning all of the function names are not erased, and we can still see them, which will make it easier to perform reverse engineering. The next thing is to try to run the binary and see how it behaves. So we are going to say / hack the world like this, and you are going to hit enter. It asks us the question, who do you want to hack? Let's say I want to hack master TVT, and hit enter, and nothing happened. Okay, we don't know what happened, just master TVT and nothing happened. So to know what happened with this binary, we need to go inside of it and see how it operates. And to do that, we are going to use a tool called Radar. So we can just write Radar 2, I believe. Yeah, Radar 2-D for debugging mode, and we are going to say hack the world like this, and we are going to hit enter. After doing that, let me see if I'm still recording. Yes, I'm still recording, and it is going great. And after doing that, we can see that now we are inside of this Radar tool. So if you are new to Radar or you are new to reverse engineering, for this video purposefully, I'm going to use the commands that are necessary for this video. If you need to see the entire help on how to use the Radar, you need to use the question mark like this. But for me, I'm going to explain each command I'm using. So if I say A like this, I'm going to analyze all of the functions inside of this particular binary and see their names as well. So if I hit enter, it's going to analyze. And to see their names, I'm going to use a command AFL like this, and I'm going to hit enter. We can see all of the functions are being displayed over here. These over here are addresses, and these are particular functions that are being called by this, or that are being used by this particular binary. So we can see there is a printf function which is used to display something to the screen. We can see system binary, we can see puts binary, we can see set user ID over here. But something that caught my eyes is this one over here, which is a dangerous function known as gets, which is notorious for being vulnerable to buffer overflow vulnerability. But also we have this binary over here called the call_bash, which means that once it is executed, we are going to see a shell that we can write commands on. Okay, so the good thing to do now is to try to load this one up and see how it looks like. So to do that, we are going to use the command S, which means seeker, and then we are going to attach the name of this particular function. So we are going to say copy, we are going to say Ctrl Shift V like this, and we are going to hit enter. After doing that, you can see the address change to that particular function over here. So after that, we are going to use PDF, which is standing for print disassembled function, and we are going to hit enter like this, and we can see this particular binary or this particular function, how it looks like inside of it. So we can see a lot of stuff over here. Okay, these all are assembly languages, but for now they are not important for you to even care, because we are just going to exploit a buffer overflow in easy way as possible. I will have a dedicated video which will go inside deep into these assembly materials. So for now, what is important is this address over here. We need to copy this address over here, and this is how it looks like once it is run. You can see it is going to print these kind of words. We are legion, we do not forgive, we do not forget, we do not forget, expect us, and stuff like that. But for this now, what is important is to take this address over here and paste it somewhere. Okay, we are going to copy this one over here and we are going to paste it somewhere. Let me go over here and let me paste it over here. Let me paste it over here, Control V like that. I've pasted it over here. Why I did that? Because once we perform a buffer overflow, we are going to overflow something known as a stack. A stack is like a buffer or something that is going to store your data. It is a data structure. And that stack consists of two things. It consists of the base pointer, which is pointed at the top of the stack. You can view it like a glass. A glass has a top and a bottom. On the top, it consists of something known as the stack pointer, which is going to point at the top of the glass. And at the bottom, it has something known as the base pointer, which is going to point at the base. And once we overflow that, we are going to enter into something known as instructional pointer, which is the register that is going to store the address of the next instruction to be executed. In our case, we need to overflow the buffer or the stack, and after that we need to replace the instructional pointer to this particular address so that it can call the bash function. Make sense? Let me show you how the register looks like. So if we go ahead to our binary, let me see my terminal over here. If we go to our binary over here and I run the command dr display registers, and if I hit enter, you can see these particular registers. For stack pointer, this one over here is the stack pointer register that I showed you over there. I just explained, I never show, I just explained. And the base pointer is this one over here. Okay, so let's try to run the command and see what happened. So if I run the command dc over here, it is going to say continue execution. We are going to execute this particular binary inside of Radar. So if I hit enter like this, we can see child is stop the stuff like that. Okay, so now we can run the command. It means that it shifted the address to this one so that we can execute it. So now if I run something like a like this, for example, this is input. We are inputting inside of this function, and if I hit enter like this, and if we say display registers now, we can see nothing changes. I don't know what I was trying to show over there, but for now, because we already have the address that we need to be executed, okay, this is the address for the call underscore bash function. But another thing that I forgot to show you is how the main function looks like. Why do we put something and it display nothing? So for that one, we're going to say follow again. Let us see how the main function looks like. I'm sorry if I just jump forward and backward because I'm doing this stuff in real time, and I'm not used to make videos, and I'm just trying to push myself. So here we are going to say S for seeker, and we are going to attach the main function, and we are going to say enter like this. And for this one, we're going to say PDF or print disassembled function, and we can see this is how the main function look like. So when we execute the program, it is going to display the following string over here. Who do you want it to hack? And once we put our value over there, it is using this function to display this one over here. And once we input our value over there, our value is being stored by this function known as gets. And the gets, as I said before, it is a notorious function which is vulnerable to buffer overflow. Meaning, if the buffer is set to 10, we can overflow that buffer by inputting more than 10 values over there. And the get function does not restrict that, it allows that to happen. And when that happens, we are overflowing registers. And our register that we need to of importance that we need to make sure that we control is known as instructional pointer register, right? So let us see how we can exploit a buffer overflow inside of this binary. So for this one, I'm going to say exit now. After doing that, we're going to say yes. And after that, we're going to say LOS. Now we have those stuff. Let us see if we have Python binary over here. We're going to say which Python, and we are going to hit enter. And you can see indeed we have Python, and this is Python 2. If it was Python 3, it would say over there it is Python 3. So for this one, we are going to try to input 80 bytes to see what happened. Let me show you in practice what do I mean by that. So we are going to say Python, and we are going to say -c like this, and we are going to use these two quotation marks to make sure that we are going to execute these particular commands. And then we are going to say double quotation mark like this, and we are going to put a. This is a string that is going to behave as the input to the hack the word binary. And after that, we are going to use the multiplication operator, and then we are going to put, we need 80 A's to be inputted inside of the hack the word and see how it behaves. And after doing that, I forgot one important thing, and that is print function over here. And after doing that, I'm going to pass this into hack the word binary / hack the word binary and hit enter. After that, you can see segmentation fault core dumped, which means that we have overflow the buffer. But this is good news at first, but we need to know something known as offset. What is the offset, or what is the value before the buffer is being overflown, so we can know where to put our address for the call_bash function. To do that, we are going to say Python. We are going to use the same command, but now we are going to try to send 70 A's to see what happened. We are going to say 70 A's like this. What happened? Nothing. It behaved normally. Now let us try to send 71 A's to see what happened. 71 A's. Nothing happened. Okay. Now let us try to send 72 A's. 72 A's. That is the point in which the buffer is overflown. So this over here, 72, is our offset, the value that is going to overflow the buffer. So after 72 bytes, or after 72 input, we need, in front of it, we need to put the address that we need to be executed. What do I mean by that? What do I mean by that? So here we are going to say Python 3 like this, right? Python 3 like this. But in front of this, we need to add a string. We need to plus and add a string for the address that we need to be executed by the instructional pointer. It means that at 72, the buffer is completely overflown, and next values are going to be inputted inside of the instructional pointer register. Hopefully it makes sense. So to do that, we need to go ahead to our address over here and turn this address into something known as Lilo Indian, meaning the last bit over here, the least significant bit, is going to be stored first. So to do that, we are going to say x58 / x 06 06 / x 40 / x 000, if I'm not mistaken, 00 / x 00, I believe, for this part over here, /x 00. Let us try if it works. Okay, let us try to see if it works. So what we're going to do, we're going to copy this one out. We are going to put it inside of over here, Ctrl+Shift+V. And to do that, we need to make sure that we enclose it inside of quotation marks like this, inside of a quotation mark like this. And after that, we are going to hit enter and see what happened. You can see Okay, do you see this, guys? Do you see this? It means that now the buffer is overflown and this address is being executed by the instructional pointer, because the instructional pointer is responsible for storing the value of the next, for storing the address of the next instruction to be executed. But for now, you can see it just run this one and it vanishes, or it exit, or let us say it stopped. Okay, so to prevent this behavior from stopping, we need to add a certain low key, or you can say a simple binary that can be found in Linux. So instead of just exiting, it is going to run that particular binary. So to do that, I'm going to use a cat binary, and to use that, I'm going to say this particular string over here, this is string over here, and after that, I'm going to add a cat binary. So I'm adding this cat binary to prevent the command, or to prevent the segmentation fault error, so that we can run a command as the user who is the owner of that particular binary over there. So for this case, I'm using this semicolon to concatenate more than one commands. So to do that, we need also to enclose this entire Python string inside of these brackets over here. I don't know if there is anyone who is watching at this point, but I'm having some fun over here. So let us continue. Okay, I'm adding this one over here, and I'm going to hit enter. And as you can see, we are legion, we are anonymous, we do not forgive, we do not forget, expect us. And if I say who the fuck am I, you can see we are user spooky. So the next thing we can do is to say LOS, and we can see there is a flag over there. Then we can cd to our own home address, and we can say LOS. We can see we have the flag.txt over there. But where the flag for spooky? I don't know where the flag for spooky. Maybe it was a desktop. Let downloads, maybe documents. Let's see if there is documents, because I don't see the flag for spooky. los-l flag.txt. Okay, this is for user Magna. It is not for user spooky. Okay, let us see if we can use the find command, find in this particular, in /home/spooky dash. We are looking for dash type. We are looking for type of file. Oh shit, let me type F. Type of file dash iname will be, the iname will be flag.txt. Let us see if we can get that. And all errors should be sent to /dev/null, and hit enter. Yeah, we can see the flag is over there. Now cd to /home/spooky. Enter. Now ls. Yeah, we can cut flag.txt. And now we have the flag for spooky use over here. We are going to copy this one out, and we are going to paste it inside of TryHackMe over here. And just like that, we have successful get the second flag, which is a proof that we have escalated it to another user. Now let us go to the journey of getting the root flag. Okay, now we are at 28. Yeah, I don't care how long this video is going to be, but I'm having fun making it. So after that, for this particular box, I don't need to bore you with a lot of materials that do not matter. For this case, the vulnerabilities that we are going to utilize in order to get root privileges, we are going to use wildcard injection. And that wildcard injection can be found inside of a cron job that is run by tar, and the root is responsible for running that particular job. So for that one, we are going to say, let me clear first tree. Yeah, it clears. So if I say LOS, yeah, it is good. So I can clear over here. Now if we go to, if we try to go to run the command cron tab -l like this, there is nothing. There is no, if I run cron, Yeah, I don't see anything over here. Cron tab. I ran cron tab. Okay. Cron tab dash L. It is doing nothing. Okay. What if I say jobs? LS. It seems like the system has actually broken. Okay, so now let me resolve this so that we can go to the journal finding the root flag. Let me pause the recording for now so that I can record that portion separately without losing this portion of recording. See you guys in a few minutes. Okay guys, the box misbehaved, but everything now it is good and back into business. So I'm going to re-exploit again the buff overflow so we can start to elevate our privileges. So after doing so, we need to cd to the /home/spooky directory over here. Okay, now we can say clear, and we can say pwd to prove that we are inside of spooky home directory. So after that, we need to go and check the cron jobs that are currently running. So we're going to say etc. We are going to say etc /cron and then wildcard and hit enter. And as you can see over here, down below, we have one cron job. And this cron job goes as follows. It is going to cd to the home directory of user spooky, and then it's going to run the tar command in order to create a backup of this home directory. But the danger is that it is using a wildcard, meaning this wildcard can be anything. And as an attacker, we are going to create something that is going to be executed by this tar command, because it is using a wildcard. Okay, so to do so, we need to utilize 2 arguments of tar in order to achieve our objective. To do so, you can see over here, this is a help menu of tar, and we are going to utilize this particular command over here, checkpoint action, and in action we are going to tell tar to execute our bash shell, and we are going to use this one in order to display the progress number, which by default is 10, but the most important one is this one over here. And to do so, we need to create this one over here as a file inside of the home directory, so it will be included as an argument by tar when it is performing its own archive. Okay, so to do so, we need to run the following commands over here. You are going to need to run the following command over here, echo this one over here. So for this echo command, the first echo is going to take all of this inside over here, inside of a file called demo.sh, and this inside over here is going to add our user spooky inside of a file known as etc sudo, which is used for access control of who can run what command inside of this particular machine. And for our case over here, we are going to run all commands as root without providing any particular password. And then for this command to be for this shell to be executed, we are going to utilize --checkpoint-action with the action of executing this particular bash shell. After doing so, we are going also to use this checkpoint in order to display progress. Okay, that is why you can see over here it is an empty file. We are creating this as an empty file, but for tar is going to it is going to interpret these as the arguments. Okay, so I've already went ahead and run those commands, and if we say ls over here, you can see they are here already. And if we display cat demo.sh, you can see the entry is already there. Okay, now let us see if that is true by saying sudo-l to see what command can we run as sudo. If we hit enter, you can see we can run all root command without providing any particular password. Okay, so in order to utilize this, we are going to say bash sudo. We're going to say sudo, and then we're going to say bash like this, so we can run bash as root. So if we hit enter, nothing happened, but who am I? We are root. We have already elevated our privileges. So what to do? We are going to cd/root over here, and we're going to say ls, and we see the flag over there. We're going to say cat flag.txt, and you are going to hit enter, and this indeed is root flag and the last flag inside of this machine. But as always, remember, we are not here to find the flags, we are here to learn cybersecurity. So for this case, we are going to the flag submission. We're going to submit our root flag over here, and we're going to hit submit, and we receive a congratulation from TryHackMe. We have indeed rooted this particular machine. If you guys enjoyed this video, please don't forget to subscribe and share with your friends. This is Master TVT aka Commando. I will see you in another video. Goodbye.